Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge. Remove stones to minimize the total. So let us first read this question, then about the constraint, and then finally about the coding part about the same. And then at the end, time complexity and the space complexity for the same. Now here, uh, let us first read the question, then we'll go ahead. So here, you are given a zero index integer array files where pile of I represent the number of stones in the ith pile. So basically pile array is being given to us in which at ith position the number of stones which is there in that ith pile that is present. Means basically the array is something like 1, 2, means 1, 2, 3. So here this represents that there is only one stone in the pile. Here it represents that two stones are in the pile. And here it represents three stones are in the pile. So that's the thing. And an integer k. You should apply the following operation exactly k times. And what that operation is about, choose any pile I. Okay, we are required to choose any of the pile which is being given to us and remove floor of pile I by 2. So basically, we will be choosing any of them and then we will be removing 3 minus 3 by 2, which gonna be uh, pile of I by 2, right? Yeah. So basically, we are required to remove from that 3 by 2. That is what we will be required to do is whatever there is, this 3 is there, right? So we will be having with this 3 by 2 only. So that is the thing. And then if it is here, so we will be removing 2 by 2 minus 2. That is now there would be 1 only. So that is a thing which we are required, and it is given that floor and seal which are there. So according to that only, means presently we are just writing like this, but whenever we will be doing floor or seal for 3 by 2, then surely they floor we all know what the answer would be. So like that only, that particular number would be present in that particular pile. So then notice that you can apply operation on same pile more than once. So basically this 3 which is given to us. First we applied the 3 by 2. Now we are having this 3 by 2. Then again we can apply this means 3 by 2 minus 3 by 2 upon 2. So this thing we can again apply on the same. So this is the thing which is required to do, but our ultimate goal is that we are required to return the minimum possible total number of stones remaining after applying the key operations. So basically the total number of stones which are being there remaining, right, after applying the key operations. So that is the thing which we are required to return. Means total number of stones which are being left after applying this key operation. Because see, at a particular pile, we can apply any number of operation, right? But that any number of operations still have a limit. That is k. So that's the thing. And ultimate goal is to require minimum possible total number of stone which are being remaining after applying that key operation. So that's the thing. And floor of x is the greatest integer that is smaller than or equal to x. That is rounds x down. Means it is the greatest integer means 3.2 if it is there, right? So greatest integer that is smaller than or equal to x, smaller than or equal to x, basically 3.2 which is there. So if we do floor of x, actually I myself forgot that what exactly floor of a particular number was. In actual like seal is always the upper limit which is there and floor should be the lower limit. So in that sense, floor returns the largest integer that is smaller than or equal to. Can I get some example also? Floor of x like 2.5, floor will be 2, minus 2.1, that will be minus 3, okay, and then 2.9, okay. Even if the number is 2.9, so here when we round it off, so it should be 3, but that 3 would be for seal and 2.92 would be for floor. So that is the thing here. So now let us go ahead for our actual question. So basically the operations which we are required to do here. Now let us first check for the example which is there. So here input piles of pile which is being given to us and k number of operation we can perform. So at the end, what the maximum possible would be left that we are required to. But just think about one thing that if there is a small means if the pile which is having less number of stones, right? Or even if there is a pile which is having large number of stones, and we are required to do C, right? So what would be more beneficial? Is removing from the max number of piles or smaller number of piles? Just think in this context. Let us sort this 9, 5, 4. Right. Every time we are required to do one operation on any one of that pile. Right. So let us choose this 9. That is the maximum which is there. 9 minus 9 by 2. So this would be again 9 by 2 only. Right. And what is the floor for the same? So 9 by 2 would be something like 4 point what would be left, right? Yeah, 4 point means 2 1 is less than 10, then point, then 10, and it would be something around, yeah, 4.4. Then when we do floor for the same, that will be 4, right? So now our new piles would be something like 4, 5, and then 4. And then again, if we sort them, so it would be like 5, 4, and 4, right? So now the largest one would be 5. I'll show you other way around also, means starting from smaller to greater and greater to smaller. First, we are doing with the greater to smaller. So for this 5, see, if we do by 5 minus 2, right? So it would be 5 by 2 only, right? And then that is 2 to 4 and point 1, that would be 9, right? Then again 2.4, then it would be 2 again, right? So now our new would become 4, 4 and 2. And they have told us that only two operations can be done. So this is one operation, right? And this is second operation. So our final okay, apply the operation on pile 2, 0, 1, 2. The resulting pile would be 5, 4, 5. The resulting pile are, yeah, 5. But how it becomes 5? That was strange. If we do, because 9 by 2 only we are required to do, right? So 4, 5, 4. One minute. If we go operation on pile 2, that is 9, that only we applied. Resulting pile are 5, 4, and 5, right? How it becomes 5 is like 9 minus 9 by 2, means whatever I is there, from that we are required to remove 9 by 2. So if we remove this, it becomes double, and then from double, if we subtract single one, it would be same only, right? Then to the 4.10 would be there, and 10 that from that less one. Okay, 2 5s that 10. But still, we are required with the floor, not with the ceiling. So how it comes out to 5? Yeah, we required floor. Okay, then we do the next step. Then it would be apply operation on pile 0, that is on 5. The resulting would be 3. In actual, we have seen the definition, right? Means floor of x. If we do the same as per TFC only, So these are example of floor. So if it is 2.5, right? So it would be 2, not the 3. I don't know why they are taking it as 5 and 3. It is it is seriously strange. Total number of stone that would be 3, 4, 5 is 12. 8, 9, 10. Okay. And then for next example, okay, then according to them, what they are doing is like this, means not taking the exact floor. And then after that, for this next example, this 4, 3, 6, 7, which is there. So first, if we take the 7, then do 7 by 2. That would be 7 by 2 again. And then it would be like 2, 3 are and 5, right? So now it will become 4. So that what they are seriously. Uh, okay, they just chose this 6 in actual. That's the thing. But how we will be doing is we will be directly choosing for the largest which would be there so that we can easily go ahead with minimizing the stones. Because see, whenever we are taking the largest one, right? So see if we have if we would have taken something like this means this would be 2, right? Means if we take any smaller one or even the even ones which are there. See if we take this. So it would be 0.5, right? So it will become 1. But if we take this 7 minus 7 by 2, which is you can see 3.5, now it becomes 4. As per their, I don't know why they have not chosen here as floor, but they have seen, means they have taken in the question that we are required to do the floor. So as per all of this, we will be first choosing for the largest number which is being there, and then after, because when we eradicate means when we eliminate half of that number, then after that, what we are required to do is we will be having a smaller number out of them, right? So like this only, it will be easier for us to make all the numbers more smaller. And that's why we are choosing for the first number, which is the larger one, and then we are going ahead with the smaller ones. And then constraints which are given to us 10 raised to power 5. So that's why n order of n log n or order of n solution would work fine, not order of n square. And 10 raised to power 4 is the maximum limit of element which could be there in a pile. Means basically content of that pile. That could be up to 10 raised to power 4. And k could also go up to 10 raised to power 5. So basically we are required to go ahead with n log n solution, else it will give us TLE. So now let us go this question. See, the way we were moving ahead with this question was that we were choosing the largest out of them. And at every time we are required to maintain the largest number. So we can't sort it again and again, right? So that's why we will be taking help of a data structure where it sorts internally by itself at every step. So that's why here we will be choosing priority queue, where we will be taking the largest number, means max priority queue we will be using. So that at the top there would be the maximum number. This would be the first thing which we will be doing. And second step would be that at the starting only we will be having the whatever what we say whatever sum is there, that we will be doing at the starting only, and we will be eliminating from that particular sum half of the largest number every time. So that's the thing which we will be doing until this k is being exhausted completely. So like this, we will be able to come up with the are minimum possible piles aggregate which could be there. So now let us code this particular question. But before coding, I've already told that what is intuition behind the same. So you could try with coding the same by your own as well. If you are stuck anywhere, then you can see the code. So now means you can pause the video and do code by yourself. So now let us go ahead with the coding part for the same. I've pre-coded the same. So I don't take much time in explanation and so on stuff. So here the thing is that we have taken the priority queue, and that is the mark C because C++ provide by default the mark C. That's what we have taken here, and then we are putting a dot big into a dot end. That simply represent putting all the elements into a priority queue. Then result, we are accumulating the sum, means total sum which is there. In actual, the actual representation of this part is running the for loop for this piles array and then adding them up. If we want to do actual implementation of this accumulate function. As in C++, this inbuilt function is there where this is the starting sum and this is the starting portion of array and the ending portion of array. So this is all. Now here comes the main part that until a k gets exhausted, till then we will be taking the top of the priority queue, then popping it out and then pushing into our priority queue again with the uh, half of that particular maximum element. Means first eliminating the half from that particular element and then pushing that back to the priority queue because we are again required. Means if that particular element could be still the greatest element, right? So it would be at the top and then accordingly we will be again performing the same operation on the same. So that's what we are doing here. And then result minus equals to a by 2. So because we have eliminated already from the priority queue was just for a processing purpose, but in actual a result is being stored in this particular part. And this is what we are going to return. Means basically what we are doing is in this priority queue, every time is this 549 which was there. Now it will become 954, right? And then after performing our operation, now it will become 54, right? But when we perform this operation, so in our result, here in the result earlier it was 9, then it was 14, and then 18, right? Earlier result was 18, but then we are after that we are required to means when it becomes this 5, then at that moment only we would have subtracted this particular, right? So that our final answer becomes something which would be the required one. So that's why we are just eliminating that a by 2 from our result. So that's the thing which we are doing here. So this was all about the same, but now comes the part about the time complexity and the space complexity. So the time complexity is because of this priority queue. Accumulate function is simply a for loop that is order of n. This while loop that is k times, right? And this order of one operation in the priority queue, but this top and pop basically in this only sorting would be there again and again, right? And this sorting will take place k into number of elements which are there, that is log n. So basically this while loop will result in order of k times because this loop will run and then log of n. Basically log of n, that's why because n elements are being there. So that is what the things would be like in this. And this is the same. Now comes the part for this accumulate function. So for this accumulate function, the time complexity is order of n, right? And the priority queue at the starting when we are pushing into the same, then again it is trying to maintain the ordered means what we say that means the order it is to maintain, right? So that is in log of in operation. So all if we if we check for all the time complexities which are there, so as per that the time complexity means total time complexity which is there is k into log n plus order of n plus log n. So to be precise, the time complexity for the same is order of into k into log n. And now comes the part for the space complexity. So basically the space complexity here is because of the priority queue which we are using. That is the only extra space which we are using. So that's why the space complexity becomes order of n. So yeah, this was all for this particular question. If you have any doubt, you can comment that down. And see, I have not used here floor, right? Because while we were doing all that, we just recognized that they are not using in actual floor by default, but I guess in C++ only it will take the floor value only rather than taking the ceil value. Sorry. I just spoke, but need to read about the same as well. Because without using the floor, it was working. So that's how I've chosen. Means I have not explicitly used the floor here. But now let us read about the same as well. That I guess by this we won't get. Actually, I just forgot. In actual, the thing was that by default, C++ will either means when we do this particular thing, means a by 2, means whenever we divide. So by default, there was a case that either it will do ceil or do floor. So in that scenario only, I was thinking that what exactly the thing is. But need to read about the same as well, and you can take this also as one of the tasks and let me know in the comments as well. Yeah, helping out the community is the best thing. So yeah, this was all for this video. If you like the explanation, please do like and subscribe to my channel, and any suggestion, then surely I need the answer in comment that what exactly C++ do by itself while dividing. Means does it do the ceil or does it do the floor for that particular? And why I'm saying just about C++ because according to language, the way priority queue here is maxi, but in Java it is minhi. So in that context only, I just wanted to know. Although I was knowing, but now I forgot. I am required to search again. But no issues. I'll read the comment and cross verify. So yeah, this was all. Thank you.